Hello everyone, welcome to a new video, or you can say the second video of the series in which we are learning about DNS, domain name server. And this is a continued section of the Cloudflare series in which we have studied the article from the Cloudflare Learning Center. And in this video, we are going to do the same, but for the upcoming sections in the DNS section. So without any further delay, let's navigate to our DNS section. Opening our VS Code, the favorite note editor, because my um, pathway has been changed, or the methodology of opening applications has been changed because I am using a tiling window manager, kind of an extension of KDE Plasma that acted like a tiling window manager. So it always opens the new or latest tab to the right side of the screen. Oh, I'm sorry, very sorry, to the left side of the screen. That's why I have to actually open the app that I don't want to use initially, which is VS Code. Then I have to open the Firefox. That explains why, and it automatically scales. So where we were, Cloudflare Learning Set. As I reach over, so we have already covered DNS in the first video. Go check that out. And in this video, we were covering what is 1.1.1.1, and it is quite a Cloudflare biased article because 1.1 is a DNS resolver operated by Cloudflare. Those who don't know what a DNS resolver is, here it is. The DNS recursor or a resolver is a server designed to receive queries from client machine through applications such as web browser. So if I am connecting this web browser's DNS resolver as 1.1.1, every query that I will be sending it to will be sent to the Cloudflare or DNS resolver. And as it says that it offers a fast and private way. Let's move to our reading mode. Yes, it offers a fast and private way to browse the internet. Unlike most DNS resolver, we also have 8.8.8.8 from the google.com. It does not sell users data to advertisers. I see what it did there. It actually targeted Google, I guess. In addition, 1.1.1.1 has been measured to be the fastest DNS resolver available. Oh my god. City. Sorry for the interruption, guys. Actually, my electricity got disconnected to pause the stream. But it doesn't affect the content that I am giving here. So, what we were studying the why use, not why use. Yes. What is DNS? So DNS, the phone book of the internet that we have already seen. We have also seen that the what are the things that are inside of DNS. We have seen the DNS resolver, which is a type of server. Yes, here the DNS recursor, also known as recursor, that manages the name to address translation, in which an IP address is matched to the domain name and sent back to the computer that it requests. DNS resolver is also known as recursive resolver. Okay? Computers are configured to talk to a specific DNS resolver identified by IP address. Usually, the configuration is managed by user's ISP, Internet Service Provider, on home or wireless connection, and by a network administrator on the office connection. Users can also manually change which DNS resolver their computer talks to. So why use 1.1.1.1? The main reason to switch to a third-party DNS resolver are to improve security and faster performance. On the security side, ISP do not always use a strong encryption on their DNS or support the DNSSAC protocol, making the DNS query vulnerable to data breach, exposing users to threat like on-path attack. In addition, ISP often use DNS record to track their users' activity and behavior. On the performance side, The ISP's DNS resolver can be slow and may become overloaded by heavy use. If there is enough traffic on the network, an ISP resolver could stop answering requests altogether. In some cases, attackers deliberately overload an ISP's recursor, resulting in denial of service. And we have a variety of DNS service. Suppose DNSSEC. While this is good security practice, does not protect users' queries from the DNS companies themselves. Many of these companies collect data from their DNS customer and use for their commercial purpose, for example, selling it to advertisers. By contrast, 1.1.1.1 does not mine user data. Logs are kept for 24 hours for debugging and then they are purged. Purge means to delete. 1.1.1 also offers security features not available from many other public DNS, such as query name minimization. Query name minimization improves the privacy by not including each query the minimum number of information required for that step in the resolution process. And what makes 1.1.1.1 the fastest recursive? The power of Cloudflare network gives it a natural advantage in terms of delivering speedy query. Since it integrated into Cloudflare's network, it spans 330 global cities. Users anywhere in the world would get a quick response from 1.1. And we have some Cisco Open DNS, Google Public DNS, and has an average ISP DNS. Okay. So what is Cloudflare Warp? Warp is an optional app built on top of 1.1.1.1. Warp creates a secure connection between personal devices, the services you access on internet. So it is quite like VPN, I guess. So while 1.1.1.1 only secures DNS query, Warp secures all traffic from your device. Warp does this by routing your traffic over the Cloudflare network rather than the public internet. The Cloudflare automatically encrypts all data and is often to accelerate it by routing it over Cloudflare's low latency. In this way, ARP offers some of the security benefits of a VPN service without the performance penalties and data privacy concern for many for-profit VPN brings. For-profit VPN means initially the VPN is for free, but they actually track every website that you visit and actually tracking your behavior may lure through advertisements. How do I use 1.1.1 and RAR? 1.1.1.1 is completely free. Setting it on desktop computer takes minutes and requires no technical skill or special software. Let's go to instruction and try to set it on our Arch Linux. Where I can, without any further ado, should I actually try to? Okay. Let's ask our beloved ChatGPT how to DNS line. Love the command line. Systemd resolved. So DNS result typically stored in HC systemd resolve.conf. I think I should copy it. Open a terminal, Control Alt and T. The console. Yeah, I have to enlarge the paste the command. My password. Yes, this is the resolve.conf file, configuration file. And yes, you can see that the Cloudflare DNS server is 1.1.1.1. It is already mentioned here. Then we have Google server, which is 8.8.8.8. And then we have Quad 9 DNS server, which is 9.9.9.9. Okay. And we have also IPv6 address for the DNS server resolver as well. And we have a fallback DNS set as Cloudflare. Okay. Is there anything else in the configuration file? Okay. Entries in this file shows the complete time defaults. Local configuration should be created either by modifying this file or a copy of this file placed in it. The HC copy of this file placed in HC. If the original file is shipped with USR or by creating the drop-ins in the HC registry result, the latter is generated recommended. Default can be restored by simply deleting the main configuration file and all drop-ins located in HC. Okay. And what we have to do next? Configure DNS server. In the resolve section, you will find the DNS and fallback DNS option. Yes, we do find it. And to set a custom, we need to modify or add these lines. Okay. So do I need to modify this? Here is resolve. I think we just have to comment out some lines. Okay. Restart this system resolve D. Why not check the status? Control X for exit. Control Shift B. Fetch to get global data. Could not activate remote peer. What if I run this command with sudo? Check with once again. Sudo systemctl resolve. Down command. Or we can directly modify the DNS server using the name server interface. Name server did it prevent automatic. Okay, so we are using the network manager in the KDE, so it will automatically override this. If I dig google.com, one second. Okay, so dig is not installed. Never mind. We have already learned enough. Close this terminal. Time to visit next article, which is DNS record. We have an overview of DNS record. One second, one second. Let me write all of it. Will certainly help me. First is a record. Second is a 4 times a record. I think writing record each time is worthless. Then we have CNAME. Then we have MX. Then we have TXT. Then we have NS. We have SOA. And we have SRV. PTR. We have a DNS key. NS. DS. And SPF. AIM. And finally, is going to be a very, very, very in-depth video. Let's begin. So the DNS record are the instruction that live in authoritative DNS server. Okay, where is the authoritative DNS server? The last step. So I have to actually make it a stepwise. So this is the first thing. Then this is the second thing. This is the third thing. Or this is the fourth thing. Yes. Yes. So this is the instruction that live in the authoritative DNS server. Okay, and they provide information about the domain, including what IP address it is associated with that domain, and how to handle requests for the domain. These records consist of series of text files written in what is known as DNS syntax. So DNS syntax is just a string of character can be used as command to tell the DNS server what to do. All DNS records also have a TTL, which stands for time to leave, indicates how often a DNS server will refresh the record. Okay, you can think of a DNS record like a business listing on Yelp. And what is Yelp? I think it might be a social platform or a business web. Western society must be familiar with Yelp, which is a restaurant, dentist, bars, beauty salons, doctors. Okay, it is a local directory service, just like the Just Dial in India. Next, the listing will give you a bunch of useful information about a business, such as their location, hours, services offered. All domains are required to have at least few essential DNS records for a user to be able to access their website using the domain name. And there are several optional records that serve additional purpose. The most common type, the A record, which holds the IP address of a domain. Okay, so A holds the IP address. 4 times A, the record that contains the IPv6 address. Okay, A holds the IP address of a domain. I should copy it and paste it here. And it contains IPv6, contains the IPv6 address of a domain. I should copy it and paste it here. Next, CNAME forwards one domain or subdomain to another domain, but it does not provide an IP address. Okay, one domain to subdomain or other domain. Forward, what it does, it's forwarding. But CNAME does not contains the IP address. Okay, next is MS record. Directs mail to an email server. Okay, directs the mail to an email server. Next, TXT record lets an admin put text note the record. These records are often used for email security. Text record actually enables to store the text. Next is NS record, which stands for name server. Stores the name server for DNS entry. Okay. Then is SOA record. Stores admin information about a domain. So SOA actually is a kind of stands for uh, security of admins. Yeah, secure credentials of admin. Next is SRV record, which specifies a port for the specific service. Okay. We will study about each in detail, don't worry. But these things to be kept in mind so we can able to compare on whichever page we were on. Okay. Next is PTR record, which provides a domain name in reverse lookups. Okay. Then it does not mention. Yes, it does mention what are the commonly less commonly used DNS records. We have AFSDB and AFS AFSDB stands for Client of the Untrue File System developed by Carnegie Mellon. The AFSDB for record function to find the AFS cells. Uh, Untrue File System. What is it? Untrue File System? Paste it in the abbreviation section. Ask it. ChatGPT. Explain Untrue File System. Untrue File System is a distributed file system that was developed at Carnegie Mellon University 1980, initially as a part of Untrue project. which aim to create a scalable, secure, and efficient environment for networked computing. And Drew file system is a system designed to provide shared access across network of machines in a way that appears that users as if the files reside on the local system, even though they may be physically stored on server elsewhere in the network. AFS is particularly notable for its efficient handling in large-scale distributed and its ability to provide high-performance file access, even in environment with limited bandwidth or intermittent connect. The key concepts are client server architecture, next is volume, third is distributed caching, fourth is authentication, fifth is namespace, sixth is replication, volume, location, and movement. Let's go to each one by one. The client server model actually explains that the client are the machine that request access. Okay, and the server where the file server cluster are organized via AFS protocol. When a client access file, the file may be cached locally for efficient access. The caching mechanism is the one of the strength. Next is volumes. The files are organized into volume, which are essentially logical groupings of files. So if anyone using Windows that sometimes may fragmented their hard drive or the solid state drive, they can see that the always new section of new partition of the hard drive or the SSD appears as volumes. So what are volumes? Which are essentially the logical groupings of files. So actually your hard drive is not being splitted but are logically divided into multiple sectors or groups. Volume can span multiple file servers and may be replicated across different servers to provide redundancy, load balancing. Redundancy means to make a copy of something or make a duplicate of something in case of failure. Suppose the main branch fails, then the other duplicate one can be used instead of that. Next, volumes are the primary unit for administration in AFS, meaning that each volume has its own access control list. Okay, volume can be moved between file servers with minimal impact. Because it is a logical grouping, the complete logic can be copied from one place to another. Okay, so it will have the minimal impact. Next is distributed caching. The AFS uses distributed caching, improved performance. For example, when a client accesses a file, it is cached locally, okay, reducing future requests to the file server and decreasing latency. Caching is transparent and AFS ensures that the client see a consistent view of file system, even if updates are happening on the server. Caching allows AFS to function effectively even in situation with intermittent. Okay, we have studied it. The ACL employs a strong security model. For example, Kerberos authentication, which ensures that only authorized user and clients can access. It is a protocol that provides secure authentication over an insecure network, and it is managed by access control list. All network engineers uses the access control list to limit or actually to filter out the IP addresses that are going to access some network or some parts of network. So via access control list, a file and volume labels can be also access controlled. These access control lists define who can read, write or execute files and directories in the AFS space. So what was AFS? Andrew file system. Namespace. It uses a global namespace, which means that files can be accessed in uniform way regardless of where they are physically stored. So namespace is a structure hierarchy and users can access file via path standard to a standard file system, both AFS, cmu.edu/user/j John Smith provide a consistent view of files across the entire AFS network. Next is replication. The AFS allows file to be replicated across multiple file servers for fault tolerance, load balancing. This means if the one file server goes down, the client can still access the data from the another replica of file, which by means is redundancy and ensures high availability and reliability. File replication in AFS is typically managed by administrator and is controlled by on a per volume basis. Next is volume location and movement. AFS abstract the physical location of files and make the movement of the volume across different servers seamless. Seamless means without any friction. This is important for load balancing and server maintenance, as server administrator can move files between server without disrupting. Now we have architecture components. We have a file server, an actual server. We have an AFS client. We have a cell, which is a logical grouping of server and clients that share a common namespace. Then we have authentication server, for example, a Kerberos authentication server. We have actually volume location server. Okay. Then we have an file access server. And we have some key advantages, which is scalability, performance, fault tolerance, security, cross platform compatibility. And we have use cases like academic and research institution, enterprise environment, and distributed application. The modern alternatives are also there, which is network file system. For simple file sharing, CEPH for highly scalable object storage and distributed file system, clustered FS, HDFS for scalable storage in big data application, and cloud storage like AWS, S3, Google Drive, which has taken over in many use cases for the ease of access, scalability, and integration with other cloud services. Despite this, AFS remains an important part of the history of distributed file system, and its principles still influence modern system. Good. Now we have APL record. Have we written the APL record? No, we haven't. So the APL stands for address prefix list, an experiment record that specifies the list of address ranges. Okay. A APL, which stands for address prefix range. Next, CAA record. Have we written it? No. CAA, which is a certification authority authorization. It allows domain owners state which certificate authorities can issue certificate for that domain. Have to copy it and paste it. Next, this is a certificate authority authorization. It allows domain owners state which certificate authority can issue certificate for that domain. If there is no CAA records, then anyone can issue certificate for a domain. These records are inherited by subdomain. Then we have DNS key record. It contains a public key used to verify the DNSSEC. I copy this. We have already written DNS key. Contains a public key, okay, which used to verify the DNSSE signature. Okay. Then we have CDNS key. This is a child copy of the DNS key. Okay. DNS key. We have a child copy too. Child copy of the DNS key record. Copy it. Next, we have CERT record, CERT. We have written it. No, we haven't. Let me. CERT, which stands for certificate record, which stores the public key certificate. Okay. DCHID record. The DHCP identifier stores info about the DHCP, a standardized network protocol. Okay, so we just have to copy it from here to here. Next one. DCHID. DSC fire. Next is DNAME. Have we written DNAME? No. So DNAME, which stands for delegation name, which creates a domain alias. So what I did learn here that just like CNAME, CNAME actually creates an alias, forwards one domain to subdomain to another domain and does not provide an IP address. Used as, and certainly write here that it is used as alias. Okay. And the next is IP address. No, sorry, HIP record. It stands for Host Identity Protocol. We have written it here. HIP records uses the Host Identity Protocol to separate the roles of IP. Host Identity Protocol, a way to separate the roles of an IP address. We will see a nice example where these type of records are used. Then we have IPsec key record. We have written it. No, IPSEC. It work with IPsec, an end-to-end security framework as a part of Internet Protocol suite. Okay, works with IPsec. IPsec. Next is LOC record, which stands for location. LOC stands for location record. Contains the geographical information in form of longitude and latitude coding. Next is NAPTR, NAPTR, which stands for name authority point and can be combined with SRV record to dynamically create URI a point based on regular expression. What it simply do is to dynamically create URI point based on a regular expression. Then we have NSEC, which stands for next, is a part of DNS is used to it's used to prove that the requested DNS resource does not exist. RRSIG, the resource record signature, record to store digital signatures used to authenticate records in accordance with the DNSSEC. Source record signature to digital. So we still haven't find about the DS, SPF, DKIM, DMARC. We have an RP record also, which is the responsible person record and shows the email address of the person responsible for the domain. So is the owner, and now we have SSHF, which stands for Secure Shell Public Key Fingerprint. Oh, stores the fingerprint of the SSH connection. Okay. Yeah, here we have DS, SPF, DKIM. Yes, the Cloudflare is an authoritative DNS service that offers the fastest response time and advanced security. The Cloudflare DNS supports a wide variety of DNS records, plus additional services like Easy DMRC, DMARC, PKIM, SPF configuration. What does this SPF stands for? Okay, so we do have an explanation, but not a small. Okay, the cloud offers a DNS resolver. Okay. Let's complete our list using ChatGPT. So if I copy it starting from here to the last thing, Control Shift and End, we copy it, paste it to ChatGPT, the list. So it only shared the only four things. So DS, and DS stands for delegation signer, record and stores the hash of DNS key record used in DNSSEC for securing delegated zones. Okay, to copy it, paste it here. And now we have SPF, which stands for the Sender Policy Framework. The record specifies which mail servers are authorized to send email on the behalf of domain to prevent email spoofing. This stands for Senders Policy Framework. Next is DKIM. The DKIM, the domain keys identified mail record, stores a public key to verify the signature of email messages. Okay, ensuring the authenticity of send. Domain key identified mail. And finally, DMRC, which stands for domain based method message authentication, reporting and conformance. Uh, Records defines the policy for email validation and reporting. Now we will do this again. Control Shift and it, and start a new chat and proof read for content accuracy fancy. A maps to an domain IP address. Okay. So it did some changes. So we will compare it to our actual data. And if I like the chat GPT's output, then we will copy that too. Okay. So DNS record. A, the maps a domain to an IPv4 address. So it does clarifies that it maps the IPv4 address. Okay. So I have to copy it. We can copy that it full. Let's check change to next one. 4 times a maps a domain to an IPv6 address. Is explicitly same. It also exemplifies it that it's an IPv6 address. Next is rename. Forwards one domain or subdomain to another domain. It does not provide an active IP address and act as an alias, which I essentially added in the last, used as an alias. Next is MX, directs the mail traffic to the appropriate mail server for a domain. Okay. Then we have TXT, which allows administrator to put text data within a DNS record, only used for verification. Next we have NS, which specifies authoritative name for a where it was, which provides the authoritative name for a server for domain. Okay, NS name server. Next is SOA, stores the administrative information about a domain, including the primary name server and domain administrator email address. Then we have SRV. It specifies a service to its corresponding port, typically used by standard protocol SIP or XMPP. This leads to other thing. It directly answers the protocol. Session initiation protocol. Okay. We have MP, which stands for where is the full form? Extensible messaging and presence protocol. At least write it. Well, messaging and presence protocol. Copy here. X X but at last, and for session initiation protocol. closed it. Next is PTR, which used for reverse DNS lookup. Here the PTR is, yes, provides a domain name in reverse lookup. So PTR used for DNS lookup, reverse DNS lookup, mapping an IP address to a domain name. Okay. Then we have DNS key, which contains a public key used to verify domain name security extension DNSSEC. Contains public key to verify domain name security extension signatures. Very good. The DS, the delegation signer, records and store a hash of DNS record. It is used in DNSSEC to secure delegated. Okay, the DS, the delegation signer, records a store of hash of DNS key record used in DNSSEC securing delegated zone. Okay, then we have SPF, which stands for the Sender Policy Framework. Records specify which mail server are authorized to send email on behalf of our domain. It helps in preventing email spoofing. So it is actually copy and pasted the thing that I've copy pasted from the Cloudflare. Next is DKey, which is domain key identified towards a public key used to verify the signature of. Okay, ensuring that the email authenticity. DMARC, which stands for domain based message authentication, reporting and conformance, defines email authentication policy. Next is AFSDB, which stands for Andrew File System. It is used to locate other AFS. Next is APL, which stands for Address Prefix List, is an experimental record to specify list address range. Okay, then we have CA, which stands for Certification Authority and Authorization. It allows domain owners to state which certificate authorities can issue certificate to a domain. If no CAA records exist, anyone can issue certificate. CAA are paid by subdomains. So then we have the CDNS key, which is a child copy of the DNS record and used to transfer to the parent to DNSS validation. Okay. And then we have CERT, which stands for certificate. Okay, it stores the public key certificate such as used for SSL and TLS. Okay, it actually added the examples. So we have DCHID identity, which stores record information for dynamic host configuration protocol. Then we have DNAME, the delegation name creates a domain alias similar to CNAME, but it redirects to all subdomain as well. Identity protocol, IPsec, LOC stands for location, NAPTR stands for name authority pointer, and records dynamic creation of URI based on regular expression and used with service like SIP, which stands for what SIP stands for session initiation protocol, and enum. Let's copy and enumerated type. A type of data containing of named value called elements, members, numerals, numerators of the type. The enums are usually identifiers that behave as constant in the language. Next, we have RSIG, which stands for Research Record Signature, and then we have RP, the responsible person. Then we have SSH fingerprint that stores the fingerprint of the SSH public key for secure SSH communication. Okay. So we will copy this ChatGPT version, navigate to our version. Okay. then we would control shift and end, delete it, paste it. That if I preview this, control shift, yes, now it looks absolutely fantastic. And we will later, and in this further video we will actually summarize, or we will actually play the quiz from this notes that I were created. Okay, we will do that too. And I think it's time to move to some next topic, which is DNS A record. To read the about DNS A record in full, in its full glory. What is DNS A record? The A stands for address and the most fundamental type of DNS record. It indicates the IP address of a given domain. For example, if you pull the DNS record of cloudflare.com, a record currently returns an IP address of this. A record only holds IPv4 address. If a website has an IPv6 address, it will use then 4 times A, quad A. The at the rate symbol in this example indicates that it is a record for the root domain, and the 14,400 value is a time to live. In seconds, the default time to live for a record is 14,400 seconds. This means that if a record get updated, it takes 240 minutes to take effect. The vast majority of websites only have a record, but it is possible to have several. Some high profile websites with several different a records as a part of technique called round robin load balancing. It distributes requests on the traffic based off several IP addresses, hosting identical content. What are DNS A record? The most common uses of a record is IP address lookup. Matching a domain name like Cloudflare to an IPv4 address. This enables user device to connect with and load a website without users memorizing and typing IP address. User's web browser automatically carries this out by sending a query to DNS resolve. And A records are also used for operating a domain name system-based black hole list DNSBL. Copy it. We'll see what does it actually mean. DNSBL can help a mail server to identify and block email messages from a known spammer domain. Okay. If you want to learn more about DNS records, you can see the original 1987 RFC where A records and a small several other DNS records are defined. Here is an article of IE Internet Engineering Task Force website. This is the implementation of A record. It actually defines all the specifications, implementation. So if you are do interested, please read it, and it is a very beautifully marked HTML document. It also supports reader view. Good. Some other day, not today, to move to another one. DNS 4 times. We will cover up to, I guess, into time. We can cover up to CNAME. And yes, this we can certainly cover the CNAME. Sorry, actually entered term R, not the DNS 4 times a record match a domain name to IPv6 address. The DNS 4 times a record are exactly like the DNS a record, except that they store a domain's IPv6 address instead of IPv4 address. The IPv6 is the latest version of internet. One of the most difference between IPv6 and v4 is that the IPv6 address is longer than IPv4 address. For anyone thinking that the IPv6 is longer, but it still take less time to process an IPv6, because it is of a fixed size rather than the IPv4 address or the actually IPv4 packets, which varies from the size. I actually don't recall how many sizes between how much bytes the actual packet varies, but it does vary, and that's why the IPv6 is faster to resolve than an IPv4. The internet is running out of IPv4 address, just as there are only so possible phone numbers for a given area code, but the IPv6 address offer more expansion, more permutations, thus far more possible IP address. Then, as an example of difference between IPv4 and v6 addresses, Cloudflare offers public DNS resolver that anyone can use by setting their device DNS to 1.1.1.1, and there are IPv4 address, IPv6 address for this service as well. Here at the rate also explains that it is a root, it is a record type of 4As which stands for IPv6 and also has a time to live of 240 minutes or 14,400. It is probable that in future all domains will have 4A record. Okay. IPv6 is growing in adoption, but it will likely to continue to be the case because the number of available IPv4 address is rapidly diminishing, often forcing multiple devices to share an IPv4 address. To combat this, the Cloudflare began turning on IPv6 for all customers in 26. But IPv6 adoption is still not complete. If I ask not ChatGPT, but I will ask the Bing GPT, Bing Chat to zoom out. 150 as of now. How many? What is the adoption IPv as of May 2024? Still, the IPv6 adoption is 44.33%. This means nearly half of internet is using IPv6, which is a significant milestone. When it will be adopted majority, the forecast. It will reach its majority status by mid 2025. By then, it is predicted that the 94% of consumer subscribers on a fixed network and 88% of subscriber on mobile network will be IPv6 ready by default. Okay. And we just have to cover a last topic, which is CNAME record. CNAME, which stands for canonical name. Did we written it here? Have to add the CANONICAL canonical name forwards one domain points from one alias domain to an canonical domain. This record is used in lieu of a record when a domain or subdomain is an alias of all CNAME records must point to a domain, never point to an IP address. Okay. Imagine a scavenger hunt where each clue points to another clue. Final clue points to treasure. A domain with CNAME record is like a clue that can point to another clue, but it does not point to a directly IP address. Okay. For example, blog.example.com has a CNAME record with value of example.com. Without the blog, this means when DNS server hits the DNS record for blog.example.com, it actually triggers the another DNS lookup for example.com, returning example.com's IP address via its A record. In this case, we would say that the example.com is the canonical name or the true name of the blog.example.com. Okay, canonical stands for true name. Okay, true name. Okay, sometimes when site have subdomains such as blog.example.com or top.example.com, these subdomains will have CNAME to point to a root domain. This way, if the IP address of the host changes, only the DNS A record for the root domain needs to be updated. All these CNAME records follow along with whatever changes are made to the root. A frequent misconception is that CNAME record must always resolve to the same website, but it is not the case. The CNAME record only points to the client to the same IP address of the root. Once the client hits that IP address, the web server will still handle the URL accordingly. For example, the blog.example.com might have a CNAME that points to example.com directly directing the client to example.com's IP address. But when the client actually connects through that IP address, the web server will look at the URL, see that it's blog.example.com, deliver the blog page rather than the home page. Okay. In this example, you can see that the blog points to an example.com as that it is based on our example. It will eventually resolve to 192.0.2.1. Okay. Can a CNAME points to another CNAME record? Pointing a CNAME to another CNAME is an inefficient because it requires multiple DNS lookups. Of course, a domain can actually be loaded. Slows down the user experience, but it is possible. For example, blog.example.com could have a CNAME record that points to www.example.com CNAME record, which then points to example.com. Okay, we have example.com, which is an alias of example, and they have a point to an A record. Okay, MX and NS record cannot point to a CNAME record. They have to point to an A record or four times A record. So we have MX and NA written somewhere. The MX and NS. Yes, this is here. Line number, which directs email traffic to the appropriate mail server for the domain name. Write it here. Not point to a NS and not point to a CNAME record. Okay, they have to point to an array or MX record is a mail exchange record. Okay, NS record is a name server record. So we did cover things in this video. I am guessing that it's already been an hour. Yes, exactly. It is an right at an hour. So I will now finish this video. I hope you enjoying studying the DNS with me, and it is such a vast topic and actually the interesting one. So I hope that you guys stick together in order to complete this one. So thank you for this video. Thank you for all the love that you're giving me. I'm actually having 50 plus subscribers, which is a great, and thank you guys. Thank you for all of this. And time to hit 10 to 20 seconds more. It's just so I can reach the 1 hour mark. So let me greet you again and again for the 10 seconds. Thank you for joining me here. Thank you guys. This stream is now being ended and hope you tune into next day.